All right, guys, good morning, good afternoon, good evening. Depends on when you're watching this video, I guess, but welcome to the wonderful world of Sig Figs, significant figures, Sig Figs for short. Sig Figs are really important when we start looking at measurements, and this is basically going to be our way of rounding in science this year, and this will continue on for you in Algebra 2 next year in physics and chemistry, so this will take you a long way. All right, so here we go. So a little bit of background on Sig Figs. Basically, Sig Figs indicate the precision of one's measurement. So it's all about this word precision. So we've got to think about what this word precision means. Precision of measurements basically depends on the tool being used. So when we talk about tool, we're talking about a measuring tool. So are we looking at a ruler that can measure to the nearest millimeter, or are we looking at a ruler that only measures to the nearest meter? You want your measurements to be precise. And precision basically comes down to how carefully your measurements are being made. When we talk about a significant figure, we're basically saying a figure, a digit that has actually been measured. So one that has not been estimated, but one that has actually been measured using a measuring tool. So here we have an example of precision. So if we look at this arrow right here, and I asked you to measure this arrow using the three rulers pictured. We look at the first ruler, and this first ruler is measuring to the nearest meter. So here we don't have any tallies, any measurements until we get to the 1 meter mark. So we can mark this ruler or arrow as being equal to 1 meter. I'm actually going to change my color here so it's a little bit easier to see. Okay, let's try this again. There we go. So this arrow would be equal to 1 meter using this first ruler. If we look at the second ruler, now we're breaking this meter down by tens. So basically we're looking at measuring to the nearest decimeter. So if now we measure this arrow, we measure it straight down to here, we see that this isn't 1 meter anymore. It now becomes 10 decimeters. So we would write that as dm. So I want you to look at the difference between the first measurement and the second measurement. First measurement, we only have 1 significant figure. Second measurement, we have 2. If we look at the third ruler, now we're looking at measuring to the nearest centimeter. So we know that there are 100 centimeters in a meter, so I would write this measurement as 100 centimeters. And actually on this ruler, I could measure to the nearest millimeter. Those are pictured as well. So really it would be 100.0 centimeters. So which ruler is going to give you the most precise measurement? Well, it's going to be the one that is going to make the most careful measurement. And that's going to be this bottom ruler because it's measuring to the smallest unit. So basically significant figures are all about measuring, and there's going to be 3 rules that we're going to follow to tell whether a number is significant or not. All right, so let's take a look at these 3 rules. All right, so rule number 1. Rule number 1 is a pretty easy rule, and it basically says that whenever we have a measurement, and it includes non-zero digits, so numbers 1 through 9, those numbers will always be considered significant. They will always be considered significant. So if we look at a number like 5, so let's say we have 5 feet. In the measurement of 5 feet, we would have 1 sig fig. What about if we had 74 inches? In that number, we would have 2 sig figs. The number 85,426, all of those digits would be significant because they're all non-zero digits. So here we would have 5 sig figs. So that first rule is a pretty simple rule. Rule number 2, which I call the hug rule. And you can all go, "Aw," hug rule. Any zeros between two significant digits are also significant. So if we look at a number like 205, here we have two non-zero digits, being the 2 and the 5. And here we have this 0 in between. So basically the two non-zero digits are hugging that 0. They're on the outside of them, they're hugging it in the middle. So that 0 becomes significant. So that number has 3 sig figs. If we add another 0 in there, now we have 2005. We still have two non-zero digits on the outside. These two zeros are significant also. So in this number we would have 4 sig figs. If we plop a lot of zeros in there, and now we have 200,000,007, we're going to have 9 sig figs. All of these zeros in the middle are significant. So whenever we have zeros in between two non-zero digits, they all become significant. So that's rule number 2. Rule number 3 is probably the trickiest of the 3. And I'm going to tell you about a trick here in a little bit, so just kind of bear with me for a second. Rule number 3 basically says, and you'll hear this said a couple different ways, that whenever we have a final 0, so that means a 0 that comes at the end, you could also refer to it as a trailing 0, in the decimal portion of a number, those are only going to be significant. So whenever we have a 0 at the end of a decimal portion, the decimal portion of a number, they will be significant. So if we look at a number like 0.110, it's going to have 3 sig figs. We know that the 2 ones, let me write this a little bit bigger here, the 2 ones are going to be significant because those are non-zero digits. Here we have a 0 at the end of the number, but whenever they're in the decimal portion, they're going to be significant. Let's take a look at the next one, 0.20400. This number has 5 sig figs. Let's take a look at it. So if we look at this first 2, we know that is significant because it's a non-zero digit. This second 0 is significant because it's in between the 2 and the 4. So according to the hug rule, it's significant. And these 2 zeros at the end are trailing zeros. So those are also significant. So we would have 5 sig figs here. If we look at a number like 0.0024, though, these zeros are not significant. I know that you would think that they would be because without them it would be a much larger number, but they're just placeholders. Placeholders are not important in significant figures. So that's the big paradigm shift that we have to get over. They are not significant. This only has 2 sig figs. Let me show you something though. Let's say we have 0.00240. In the past you might not have think that this 0 mattered. But when it comes to precision, we're actually saying that this 0 has been measured. So this 0 would be significant. So if we're looking at this number, this would actually have 3 sig figs. However, whenever we don't have a decimal, as in 24,000, these trailing zeros, again, they act as placeholders. If there's no decimal point at the end, these trailing zeros are not significant. So this number only has 2 sig figs. So let me show you this trick that's going to help us out with rule number 3. All right, so this trick is called the Atlantic-Pacific rule. Atlantic-Pacific rule. So we're referring to the 2 oceans here. So you've got to think about the continental United States and watch my beautiful picture of the continental United States. You like that? I know, it's good. The Atlantic Ocean is going to be over here on the right-hand side. Pacific Ocean is over here on the left-hand side, or East Coast, Atlantic, West Coast, Pacific. This trick is gonna help us remember when to ignore zeros, so zeros that are not significant. If a decimal point is present, like in Pacific, think P, if it's there, you're going to ignore zeros on the Pacific side, or the left side of the closest non-zero digit. So in this case, if we look at a number like 0.000704, the decimal point is there, it's present, you're going to ignore all the zeros on the left-hand side of that number 7. So this only has 3 sig figs, the 7, the 0, and the 4. Let's do another one. The decimal point is present, so 0.02. Zeros to the left of the closest non-zero digit, this number 2, are ignored because the decimal point is present. So this only has 1 sig fig. On the other end of it, if the decimal point is absent, we're going to ignore zeros on the Atlantic side, the right side of the closest non-zero digit. So if we look at a number like 761,000, it only has 3 sig figs. It's these first 3 numbers on this side to the right of the closest non-zero digit, that number 1, are ignored. So there's only 3 sig figs here. That rule will be very helpful. This rule is going to take a little bit to get used to, but with a little bit of practice, you'll get this in no time. I promise. Just stick with it. All right, so now we're doing math with sig figs. There's some basic rules that we're going to follow when adding and subtracting, and there's going to be different rules for when we multiply and divide. In addition and subtraction, you're going to select the number with the least number of sig figs. So if you're looking at 2 numbers, you're going to select the number with the least number of sig figs, and you're going to round your final answer to that number of sig figs. In adding and subtracting, we're only going to be looking at sig figs to the right of the decimal. So if we have a number like 25.40, we're only going to be looking at these numbers. So over on this side, we have 2 sig figs. The 4 is significant because it's a non-zero digit. The 0 is significant because it's a trailing 0 in the decimal portion. If we have a number like 25, well, 25 doesn't have any numbers in the decimal portion. So we would consider that to have 0 numbers to the right. So we would need to round our answer to the nearest 1. So you're going to add, subtract as normal, and then round to the smallest number of sig figs. Let's look at some examples. In this first example, 1.1 plus 1.12. We know that we have 1 digit to the right of the decimal point in this first number. We have 2 digits in the second. So you're going to do the addition as normal. We get 2.22. We know that we only want 1 sig fig in the decimal portion because this number only had 1. So we're going to round this normally. 2.22 would round to 2.2. You know, if it's 4 or smaller, you're going to round down. 5 and up, you're going to round up to the nearest number. Let's take a look at another one. 402.663 plus 3.21 plus 88.60385. You have to count the sig figs up. So in this first number we have 3, in this second number we have 2, and in this third number we have 5. So we pick the smallest one, which is 2. That's what you're going to round to in the end. But you have to do the math first, and then you're going to round, in this case, to the nearest hundredths place. So the 6 tells that 7 to round up to 8. So you end up with 494.48. So that's adding and subtracting. Multiplying and dividing, is a little bit different. In this case, we're still going to select the number with the least number of sig figs, and we're going to round our final answer to that number. But in this case, we're looking at all numbers, not just numbers to the right. So it's actually a little bit easier, which works out for us because mostly we're going to be multiplying and dividing. So we're going to round answer to the smallest number of sig figs after multiplying and dividing. A few examples. 27 times 3. In the number 27, we have 2 sig figs. In the number 3, we only have 1. So we're going to multiply as normal. 81, we only want 1 sig fig in our answer. So we would round down to the nearest 10, which is 80 in this case. 80 has 1 sig fig in its answer. In 3.01, we have 3 sig figs. And 1.1, we have 2. Remember, when we multiply and divide, we're looking at the whole number. The answer, 3.311, has 4 sig figs. We need to round to 2 sig figs. So we need to round to the 10th place in this case. 3.31, that 1 tells the 3 to stay the same, so we end up with 3.3. And then finally, 45.62. We have 4 sig figs, 3.1 we have 2. We end up with this big long number. We only want 2 sig figs in our answer, so we're going to have to round to the nearest 1. So this is going to round up to 15. And those are pretty much the basics of significant figures. If you need to go back and listen to a part of this lesson again, I urge you to do that. And then I want you to do some practice on your own. I know it's a little bit scary at first because this is new, but I promise after a day or two, you'll get this and it'll be routine for you. Good luck.